Hey guys, welcome to the third and final video of a three-part tutorial where I'm sharing how to calculate how long and how far a scroll rect will scroll after the user ends a swipe. We took care of all the math derivations in the last video, so now we're finally ready for implementation, and we're going to do it with less than 5 lines of code. And if you'd like to follow along, I included a download link in the description. In the scene, there's a scroll rect that we'll add velocity to via code, and at the top are labels to display the expected duration and distance, the part we're going to implement, and labels to display the actual values output from the scroll rect. Also, note that I'm using my scroll rect, which contains the Unity source code copied straight from their Bitbucket repository. With that said, let's get started. All we have to do is copy the equations we derived last video. So we have duration equals mathf dot log of vf over v0 divided by mathf dot log of r. And for distance equals vf minus v0 divided by the natural log of r, and then times sign. So if we look at the scroll view, you can see the deceleration rate is 0.135. And on our custom test script, the initial velocity is set to 500. Let's test. Click Run Test. And duration is pretty similar, but expected distance is off by about 4 or 5. Let's try doubling the initial velocity and see what happens. Oh, even worse. Our error pretty much doubled. And let's double the initial velocity again to 2000. And once again, the error got even worse. So what's going on? Why is the scroll rect distance so far off from the expected value? It turns out the culprit is actually the position update. Let's take a look at the velocity time graph to see why. Let's say we have delta time values at 0.25, 0.5, and 1 second. Recall that we're trying to find the area under the curve. Think of it like this. Velocity times delta time equals height times width, the area of a rectangle. But we're dealing with a curve, so the rectangular segments are only estimations. If we update the position after updating the velocity, it means the top right corner of the rectangle is touching the curve, which as you can see leaves gaps at the top, causing it to undershoot the distance. This is what the Unity scroll rect does currently. In contrast, if we update the position before updating the velocity, it means the top left corner of the rectangle is touching the curve. This results in overshooting the distance. So we need to try balancing those two scenarios by using the average velocity of this frame and the previous frame to update the position. Okay, we start by saying previous velocity is equal to the current velocity, and then after the velocity is updated, we have average velocity is equal to current velocity plus previous velocity minus current velocity divided by 2. And then we use that average velocity in place of the current velocity in our position update. So that should do it. Let's try it out. Wait for it to load. And again, the initial velocity is at 500. Run test. And much better. Less than 0.1 off. Let's try 2000 as an initial velocity. Run the test. Once again, about 0.1 of error. And finally, we'll try 4000. And this time, only about 0.2 error, so this is much better than before. And that concludes the tutorial. I hope it was helpful, and if you have any questions or comments, just leave them in the comment section below. Until next time, Game Constructor signing out.